In this video, we're going to continue with another example of applying the chain rule, specifically when you have a constant in the numerator of a fraction. Take a look at this problem. You could use the quotient rule here, but there's a much cleaner way to do it. How can we rewrite this in a form we can apply the general power rule? The key is to rewrite the function so it is in a fraction. So how can we do that? We can do that by bringing the denominator up to the numerator by changing the sign of the exponent. So g of t becomes negative 7 times the quantity 2t minus 3 raised to the negative 2. Now this is much easier to differentiate. Now we can use the general power rule, which is a form of the chain rule. In this example, we'll set 2t minus 3 as the inner function. I'll label that u. To get the derivative, g prime of t, let's bring the exponent down and multiply with the constant, negative 7. So negative 7 times negative 2 is 14. We're going to multiply that by u, raised to the negative 2 minus 1 power, which is negative 3. Now we can substitute the inner function back in for u. 2t minus 3. Next, we multiply by the derivative of the inner function. The inner function is 2t minus 3. The derivative of 2t is 2. Let's combine the 14 and the 2 to make that 28. And finally, we can rewrite what we have with the positive exponent. So let's recap what we did. When you're differentiating quotients with constant numerators, rewrite the function so you can use the chain rule instead of the messier quotient rule. Rewrite, differentiate, simplify.